You see these headlines all the time, right? Drinking coffee helps you live longer, or screen time causes anxiety. The news is just flooded with them. Well, today we're going to break down the one critical thinking tool you need to tell what's real from what's just noise, the difference between correlation and causation. And once you get this, it's going to change how you see, well, pretty much everything. All right, so let me ask you a kind of weird question. Does sleeping with your shoes on cause a headache? Sounds ridiculous, right? But what if I told you that statistically speaking, there's a real strong link between those two things?
Yeah, it's true. I'm not making this up. Statistically, there is a strong positive correlation. And if you stick with me, I promise that by the end of this, you'll know exactly how that's possible and what's really going on.
So, to crack this puzzle, we got to get our heads around the tool scientists use to find these connections in the first place. And that tool is called a correlational study. The most important thing to get here is that researchers aren't, doing anything to the people they're studying. They're just watching. They're measuring stuff that's already happening out there in the wild. This chart really lays it all out. See, in a classic experiment, a scientist messes with something, they manipulate a variable to see what happens. But with a correlational study, nope, it's hands-off. It's all about observation, not intervention. Okay, so if these studies are just about looking for links, how do scientists actually read them? What are they even looking for? Right, so any correlation has two main parts you need to know about. First up is its direction. And basically, it can go one of three ways. First, you've got a positive correlation. And this is super simple. It just means both things move in the same direction. If one goes up, the other one tends to go up too. Think about it. The more hours you study, the higher your exam scores are probably going to be. They rise and fall together. Next, you have a negative correlation. And a good way to think about this is like a seesaw. When one side goes up, the other side goes down. So, the more time you spend on non-study stuff, the lower your exam marks might get. They move in opposite directions. And the last one is, you guessed it, zero correlation. This just means there is absolutely no relationship between the two things. Like the amount of coffee you drink and your final grades, probably no connection there at all. Totally unrelated. Okay, so that covers the direction. But what about the strength of the relationship? How strong is this link? Well, for that, scientists use a number called a correlation coefficient. And it's always a number somewhere between -1 and +1. It's pretty easy to read. The little sign in front, the plus or minus, that tells you the direction we just talked about. The number itself, that tells you the strength. The closer that number gets to either +1 or -1, the stronger the connection is. But if the number is really close to 0, it means the link is super weak, or maybe there's no real relationship there at all. All right, so now we know how to read these things. We know about direction and strength. Now we can finally tackle the single biggest, most common trap people fall into. And here it is. Seriously, if you remember only one thing from this whole explainer, make it this. Just because two things are correlated, even if it's a really strong correlation, that does not prove that one thing is causing the other. Ever. But why? It seems so logical, right? If two things are connected, why isn't one causing the other? Well, a lot of the time, the answer is something called the third variable problem. It's like a hidden puppet master in the background, a secret factor that's actually pulling the strings on both of the things we're looking at. Let me give you a classic example. There is a very strong positive correlation between ice cream sales and the number of assaults reported. So, does eating a vanilla cone make you want to go pick a fight? Of course not. That's ridiculous. The hidden third variable here is hot weather. When it's hot, more people buy ice cream, and also when it's hot, people can get irritable and tempers flare. The heat causes both things to go up. And that brings us right back to where we started. So, does sleeping with your shoes on cause a headache? No, of course not. The sneaky third variable is probably drinking too much alcohol the night before. Think about it. Drinking too much can make you pass out without taking your shoes off. And it also, gives you a massive headache the next day. The alcohol causes both. Okay, so right about now, you might be thinking, well, hang on. If these studies can't even prove what causes what, what's the point? Are they useless? And that is a huge mistake. They are actually incredibly important. They're absolutely essential. I mean, think about it. How else could scientists study something like the long-term effects of childhood trauma? You can't just give people trauma in a lab experiment. That's completely unethical. So we use these studies to spot those real-world links, which give scientists really important clues about where to investigate next. And, this is the big one, they allow us to make really useful predictions. So, for instance, tons of research shows a strong positive correlation, we're talking like a plus 0.70, between having high levels of stress and how likely you are to get sick. Now, again, does this prove that stress directly causes you to get sick? Nope, not on its own. There could be other factors, maybe stressed people don't sleep well or eat right. But what that strong link does let us do is make a really powerful and helpful prediction. It tells us that if your stress levels are high, your likelihood, your chance of getting sick goes way up. And that's the key word here, likelihood. A prediction isn't a crystal ball. It's not a guarantee. It's all about probabilities and managing risk. But knowing those probabilities is super useful. It lets us make better choices. Like, hey, I'm really stressed right now. Maybe I should focus on managing that before I get totally run down.
So, you see, correlation is this amazing tool for prediction, even if it can't give us the final answer on what causes what.
So, I'm going to leave you with a challenge. The very next time you see a headline that says something is linked to or associated with something else, what's the first question that's going to pop into your head? If your brain immediately starts hunting for that hidden third variable, then congratulations. You're already thinking like a scientist. Thanks for diving in with me.